Topic of today's discussion is the challenges in salinity monitoring in an estuary. Before going to the discussion, we should know what an estuary is. The rivers, which are mostly perennial in nature, have its mouth in the sea or ocean. When there is tide in the sea, the water level rises and river flows inward in opposite direction due to high potential of seawater. Again, it recedes back during ebb time. In India, this tidal influence occurs twice a day. The stretch along the river where there is influence of tidal is normally called estuary, where the fresh water and the salt water mixes up. But the definition is not so easy as I said. However, I will make a separate presentation or the topic of discussion on estuary separately. I will discuss this estuary elaborately in a separate technical session. Depending upon the topography of the area, the estuary stretch may be 50 km or even 300 km as per the river bed slope. For Hooghly River, which is in the eastern part of India, it stretches to about 175 km. However, the issue which bothers most is that during the tidal period, there is an ingress of saline water or the salty water within the estuary, which we normally call saline water or salinity in river. The population, irrespective of whether it is in urban or rural, who consume river water for their normal domestic purposes, gets affected due to many adverse effects of salinity. It may be water quality, ecology, climate change and ecosystem, pisciculture, animal life and plant life, infrastructure, crop yield and agricultural production, wetland management, soil and soil erosion, enhancement of repair and maintenance cost, and many others. For the water supply authorities, it is a big challenge, big challenge. There are many solutions to get rid of salinity effect. One easy solution to mitigate this issue or reduce salinity effect is to draw water during non-tidal period where there is no or less saline water in the river. Hence, there is a requirement of monitoring, rather I should say real-time monitoring of salinity parameter in the river. Based on the monitoring, the salinity parameter, rather salinity forecasting or salinity prediction can be done through hydrological modeling. Though this modeling is not the topic today. There are many challenges in salinity monitoring, which I would like to discuss today through one case study. A study was done in Hooghly Rupnarayan Estuary. A schematic map of the river is shown here. Here you can see the area of discussion is shown in red dotted line. 3 monitoring stations were selected along the river stretch. The river stretch, as I said earlier, is in the eastern part of India. The monitoring stations were in Haldia, Gyeokhali and Kolaghat, approximately 30 to 35 kilometers apart. The selection of monitoring locations were based on the different factors like detectable variations in salinity along the length, possibility of engaging security provisions, presence of permanent structures for installations, analysis of historical data of HFL, that is high flood level, easy to access but away from public reach, preferred to be in government lands or the government authorities area. Having good network connection is a prime factor as the monitoring system is all real-time data flow. I repeat, real-time data flow is essential for monitoring purpose. The owners of the stations which were selected are Ship Berthing Jetty of IOCL, that is Indian Oil Corporation Limited in Haldia, Water Intake Bridge of WTP in Gyeokhali of HDA, Haldia Development Authority, and similar bridge WTP intake in Kolaghat of PHED, that is Public Health Engineering Directorate. Different stations had got different challenges which the agencies faced during installation and monitoring and even maintenance. However, the first challenge is to procure the appropriate instrument. It involved inspection, trial run in pilot scale before installation. In order to make a good salinity forecasting, a hydrological model needs to be established, for which monitoring of other parameters like rainfall, water level, evaporation, wind speed, etc. is also required. Different companies have its own calibration curve for salinity meter. It needs validation from primary data. That exercise was done in government accredited laboratory by examining the samples taken from the river at those monitoring locations at different times of a day and correlating with the instrument data. Here, the real challenge is to establish the correlation factor. Procuring different companies' instruments for a single stretch of river in a single project is not applicable or recommendable. Installation of other instruments which are required for appropriate salinity prediction in wider scale has different level of challenges and will be discussed in a separate session. In a year, salinity varies monthly, diurnally, and hourly even. The second challenge is to fix up how many random samplings needs to be taken and for what time period in a year to correlate the instrument data. A probabilistic approach is required to derive on this. A pre-planning is essential based on the available budget. So here the challenge is mainly the time factor. Now let me discuss the challenges in Holdia site, IOCL jetty site. In Holdia site, there were many challenges. As it is a berthing jetty for oil, it is highly sensitive area. Getting permission from the authority was a big challenge. The second challenge was to fix the instrument on the pylon, on the structure. Nailing or screwing a frame to fix up the instrument was not allowed. So the option left was to tie the instrument with the jetty column or pylon from riverside. It was possible to tie at the lower level but not at the upper level where the tide water does not reach. It was not a permanent solution at all. There was lack of stability and so frequent inspection was required. During high tide wave situation, the instrument was prone to get torn from the cable and get lost. It happened so. It required replacement which enhanced the cost of monitoring and operation. Other challenges was access prohibition during ship berthing. So easy access was not expected. Hiring a boat to install and inspect was a challenge. The authority gave permission to the agency but not to the boatman who was local there. Accumulation of solid on sensor floating frame was a challenge with respect to maintenance issue. Now, let us come to Geokhali site challenges. The sensor was installed on the WTP intake jetty. The location was very much within the reach of normal public and passerby. The security was an issue there. There was a need of 24/7 security services. The other challenges were intake structure not in satisfactory condition, clamping of instruments to the bridge was in vulnerable condition, minimum draft in the dry season was an issue. Hence, there was a requirement to hang out the cantilever frame structure more, which was previously not estimated. For Kolaghat, the site challenge was unique. The site, unlike Geokhali, was protected by the authority. But the problem was the local fishermen. They had a misunderstanding to interpret the sensor probe arrangement as hidden camera. Most of them were illegal fishermen was in a notion that this instrument was for surveillance. In the night, they used to come from the riverside and tear the cable off. It continued until the authority advertised the purpose of the sensor through local meetings and notice boards and notice banners. This challenge was unique and was beyond expectation for any planner, administrators, or engineers. The other common challenges were mostly physical, that is access to the site in adverse condition, climate condition, maintenance and also identifying the benchmark for appropriate authorities. Hope you enjoyed this session. You know the requirement of salinity monitoring, but there are many major and minor challenges which an expert consultant need to consider before planning, whether it is time or budget. Thanks to the viewers for enjoying this session and participating in this session. Thank you.